Hey, welcome to our next session, everybody. Hope you've been enjoying the day. Just a couple more things to go. You're going to want to make sure that you head to the round tables and then go to the stage later on for those prize drawings. But we're going to start it off. Open up your group chat. You should be able to have that right there. Open up your group chat, and we're going to play a little trivia, ask a couple questions, see what you know. All right. Number one was, which Florida beach is known as the world's most famous? Make sure to put your answers in group chat. Which Florida beach is known as the world's most famous? That is right, Ryan. Daytona Beach is the right one. Daytona Beach. You got it. Good job. Good job. He's quick on the finger there, trigger finger, getting that in. Next one, we're going to go with the second question. What is the largest river in Alabama? This might be a little more difficult. What is the largest river in Alabama? Throw your answers in the group chat. You get a chance to get one of those CUGC mugs. So that you can at least walk away sometime. Oh, Tom, I think think that might be the right of the Tennessee. Yeah, the Tennessee is what we were looking for. Tennessee. Yeah, that is Mike. It looks like Mike G. Looks like you got it. Oh, wait a minute. Seiya K. S-E-Y. Yeah, it looks like that might be the winner right there. So let's look and check. No, it looks like it was Mike G. Mike G, you were the quick on that trigger finger for that one. So you'll be getting one of those. Now, we're going to want to hang around here because Rich is coming on, Rich Faulkner. He will be presenting Hyper-Convergence, the what, how, and why. What, how, and why. So, Rich, I think you can take it away, sir.
Okay, how's everybody doing? I just wanted to point out that we are actually, I'm located in Chattanooga, Tennessee, right on the border of Tennessee and Georgia, and about 5 miles from Alabama, where the Tennessee River does roll into the state of Alabama. So I want to thank everybody for being here today. These are supposed to advance here. There we go. Thanks, everyone, for coming out today to our virtual Southeast User Group XL event. I'd like to thank the CUGC team and the regional leaders for putting this all together and inviting me to speak. I have to say I'm a little bummed that I wasn't able to do it as an in-person event. I've attended several XLs in person, and I really enjoy them. But, you know, COVID has got to ruin everything. Somebody did ask me one time what the worst investment was I ever made, and I said a 2020 planner. I'd like to also thank the sponsors for their efforts in making all this possible. Please make sure you go by the booths and visit with them and learn about their technologies. I think there may be one of them that likes this topic that we're talking about today and have a few things to say themselves. And of course, without the sponsors, we wouldn't be able to bring you this great content. A little bit about me. I'm Richard Faulkner. I'm an enterprise solution architect and a Citrix technology professional. I've been working with a company called Conversant Group. As I said, I'm in Chattanooga, Tennessee. I've been in the IT industry for about 24 years. First started working with Citrix when it was called WinFrame. I've been certified since they had a certification. I've actually helped write Citrix exams, offered my input to the program managers, etc. I have so many certifications, I just tell people I'm certifiable. But I haven't always been an IT guy. I actually started as a nuclear engineer on submarines. This is a picture of me standing the lookout watch as we were navigating into the port of Gibraltar. I cropped out the year. I think I may have changed a little since then. It was actually in the Navy that I started using computers, and the micromanagement of nuclear power led me to re-career myself when I got out. By the way, the favorite thing I did in Gibraltar was a pub crawl. You ever get a chance to participate in a pub crawl? I highly recommend them. I do ask that you follow me on Twitter at RJFaulknerJR, and let's go ahead and link up on LinkedIn and / Richard Faulkner Jr. Keep wanting to hit the arrow key, that doesn't work. Our agenda today is to learn about hyperconvergence. If we were meeting in person, actually I'm going to ask the question while we're sitting here. I'm going to send a pulse check out here, and give me a thumbs up if you've heard of hyperconvergence and are and learned about it, and a thumbs down if it's new to you. Kind of curious how fast we'll get responses on these. There we go. Starting to get a little bit. One person answered. They've heard of it. All right. Now we're getting a little further. It looks like a good chunk of the group here has heard of hyperconvergence before. Let's do another pulse check. We'll end that one. We'll send another one. Let's say if you are using hyperconvergence, give us a thumbs up, and if not, thumbs down. Get an idea how many people have actually put it in play. If you've used it in any form, even if it was in previous jobs, you can go ahead and answer that in there. Yeah. So it looks like we're about half the people have answered, and about that many are using it. So it's a good chunk. People have been using it. I'm going to go ahead and end that so we can move on with things. What we're going to do today is we're going to talk about what is hyperconvergence, what brought it about, what kind of advantages does it bring over your conventional three-tiered architecture. How did we get here? After that, we'll talk about how is hyperconvergence accomplished. While there are a lot of hyperconvergence vendors, and they will all tell you how they are different, and they truly are different, there are some basic fundamental pieces that make a solution hyperconverged. And finally, we'll discuss why you would consider hyperconvergence for your VDI deployment. Hyperconvergence is very useful for many different workloads, but it lends itself very well to virtual desktops, and we'll discuss why that is. We'll give you some tips on finding out more information on hyperconvergence, and then later on after the session, we'll have the roundtable discussion so you can ask any questions you have, and we'll go through them. So let's get going on it. What is hyperconvergence? Wikipedia defines it as a software-defined IT infrastructure that virtualizes all of the elements of conventional hardware-defined systems. At a minimum, this includes virtual computing, meaning we have a hypervisor, a software-defined storage, and virtualized networking. Hyperconverged infrastructures are usually accomplished utilizing industry-standard servers or machines you can buy off the rack. If we look at the evolution of infrastructure that brought us here, we'll start with the traditional three-tiered architecture. We started out with a bunch of servers, and I mean a bunch of servers. These servers were connected to shared storage devices, which converted a bunch of disks into a logical storage unit presented usually via fiber channel switches. This was great for what we wanted to accomplish, but it took up a bunch of data center space, as we needed a separate physical server for each workload we had running. Many of these servers were underutilized, consuming only 4 or 5% of the resources most of the time, but they all had minimum requirements that were specified by the vendors, and of course the vendors always thought they needed everything. This also required that we have teams of people who knew how to set up, manage, and maintain the servers, the storage, and the networking. This meant that you had to have switching experts, storage experts, and server experts. If you wanted a disaster recovery facility, you had to double the cost and double the complexity. Not to mention that many of the workloads did not have a means of existing in 2 data centers at the same time. The first step in reducing the complexity was virtualizing the compute and the storage networking. By software defining these, we greatly increased the flexibility of the design. This allowed us to reduce the number of physical servers. It was truly impressive to see the reduction. The first deployment I did with virtualization literally reduced 3 rows of racks at 5 racks to a row down to 1 rack of blades and a half a rack of storage. Many data centers went from out of space to let's go play racquetball in the back end. By virtualizing the compute, we were able to reduce complexity a little for DR, as the virtual machine could then run on any device that ran that particular hypervisor. Gone was the need to have identical hardware at each end, although the storage devices were often identical and replicated from point to point. This required a very big pipe to replicate all that data over. At this time, manufacturers started to package the servers, switching, and storage into a bundled appliance. Often this package came with simplified management console. This gave companies a turnkey appliance that managed the different pieces from one common console. It reduced the complexity of the environment as well as the expertise required to operate it. This converged infrastructure is still in use today. Many of you may have heard of Cisco's Flash Stack, where they team it up with the Pure Storage. HPE's got the CS700s and so forth. They're frequently purchased as point solutions like an SAP HANA or artificial intelligence and machine learning. You can buy a pre-built package that is guaranteed to handle a particular workload. But this still had some complexity in management and setup, plus it did not lend itself to other workloads in addition to what it was purpose-built for. Eventually, we started software-defining everything, which meant virtual networking on the data and network sides, as well as the virtual storage devices. Once this was a reality, a couple of smart people thought, why don't we software-define everything in traditional off-the-shelf servers? That's probably not actually how they thought about it, but it sounded good in my head. Finally, the hyper-converged infrastructure was born. By moving to utilizing the storage in industry-standard servers and running a controller appliance on the storage on each node, we can remove the complexity of the storage device completely. Everything is now managed from the same console, and it is very easy for an IT generalist to maintain. Software definition of everything is what truly makes the cloud possible, and hyperconvergence makes private cloud very possible. The hyperconverged infrastructure brings us many advantages. The first is the ability to quickly set up and deploy the infrastructure. IT departments can scale quickly as hardware can be set up in a few hours. Hyperconvergence also scales linearly because there's a known quantity of compute, memory, and storage for each node added. So if I need to add some more compute and pieces, I just add another node. It decreases the time required to expand the environment as the needs arise. Most hyperconverged offerings also now include the ability to scale compute and memory without storage by utilizing compute-only nodes. This flexibility makes the IT team's job much easier. When resources run low, increasing them is as easy as adding in another node. If we ask what it will take to support another workload, we just need to figure out how many nodes we need to add. With software-defined everything, reliability can be ensured without the complexity of maintaining several different silos of duplicated data. Switching and compute. Built into each cluster of nodes is the ability to protect the data without requiring separate controllers and disks. Many hyperconverged infrastructures come with backup and disaster recovery options built in. From the same management console, you can ensure your data is safe, and setting up a second data center is as simple as adding the nodes and replicating the data. Without the built-in built-in management of this solution, failover to a secondary site is push-button easy, as is resynchronizing the data back and failing back. I believe that the best business continuity plans run the business on each of the data centers half of the year. This proves beyond a shadow of a doubt that the business continuity plan works. Most hyperconverged vendors have the tools built in to make this simple. Efficiency is increased because IT can eliminate the need for manual processes to add resources, as well as removing the need for siloed operations expertise. Now, a single team of IT professionals can easily deploy, configure, and maintain the environment. With software-defined everything, things like data deduplication and compression are built in, so storage consumption is even more efficient. This brings SAN performance to the server level. We also gain efficiency with the reduced power and cooling loads needed, as the infrastructure doesn't need the extra hardware of the SANs and the switching. But how is hyperconvergence achieved? Software-defined everything is the core of hyperconvergence. You start with virtualizing the compute and memory, which requires a hypervisor. All hyperconvergence vendors utilize one of the modern hypervisors and then build their plugins in to define the remaining portions. In fact, most of the hyperconverged vendors support multiple hypervisors. A virtual appliance is then added, which manages the definition of the storage. Local disks on those servers are then virtually defined as a storage object. All manner and types of hard drives can be utilized. You can have NVMe and SSD as a fast cache for frequently accessed data, while spinning disks can contain the long-term storage objects. This storage is replicated between nodes. Additionally, data deduplication and compression can be applied to save the storage space, much like most modern SANs. And finally, the networking virtualization can be handled by the software in conjunction with the hypervisor's network virtualization. V-switching and segmentation is push-button easy. The installation scripts create much of the networking required to make the hyperconvergence possible. Some options also add the ability to software-define the physical switches themselves. All your infrastructure from one easy-to-use console with point-and-click simplicity. Creating a hyperconverged cluster is easy. Usually you will want to start with a runbook and fill out the answers of each of the questions you'll be asked. Things like what are the IP addresses for the storage, the node, storage virtual appliance, etc. Booting a machine to an install device, usually a USB device, executes the install script. When you run the script at install, you'll fill out the answers from your runbook. Once all of your variables have been asked and answered, the install begins. You can usually go drink a cup of coffee and have a bagel, as this will take a little bit of time. Once the process completes, your cluster is built and your nodes are online ready to accept VMs. They include the tools to migrate your existing environment if necessary. The management consoles are easy to utilize, and for many offerings, the plugins run from the hypervisor's console itself. If you need to expand your environment, you simply purchase more nodes, run the same scripted install. Once it completes, you see your resources available in the console. Your drive sizes improve, you see the nodes, and you just move machines back and forth. You might ask who is doing hyperconvergence. Nutanix pretty much started at the trend, and as you can see, is still the market leader. The recent Gartner Magic Quadrant shows just how crowded hyperconverged market is. Big names, of course, are in the upper right, are no surprise to anyone, but there are plenty of contenders. Almost from the time hyperconvergence was created, virtual desktop infrastructures have been deployed on it. So why is VDI such a popular workload for hyperconvergence? What makes this particular solution a better fit for my virtual desktop infrastructure? VDI workloads tend to have a linear increase in demand. For every user desktop, I have a known quantity of compute, memory, and storage, both in size and in I/O. This makes it very simple to figure out how many workloads can be carried per node, making sizing and increasing capacity as easy as adding the required number of nodes. If I need to add 100 more users, I simply acquire the number of nodes I need, spin them up utilizing the script, and I'm ready to deploy. It's highly recommended if you're running both server and desktop virtualization that you use separate hardware to support each. We do not want a server backup to slow down everybody's desktops, nor do we want someone surfing the web or doing a Teams meeting to slow down our database servers. With hyperconvergence, not only can we run a separate cluster, it's easy to segregate the management capabilities between the desktop and the server teams. Because hyperconvergence does not require expert skills in 3 different silos of hardware, it's much easier to manage. This allows organizations to offload the management of the environment to IT generalists, or even for some larger organizations, to the desktop team themselves. This eases the burden on the infrastructure team by giving the easy button when it comes to deploying and maintaining the environment. With hyperconvergence, it's very easy to ensure business continuity. From already knowing the hardware you need to easily being able to set it up and having built-in tools for handling the replication and failover, hyperconvergence makes business continuity a breeze. It's funny, when I would discuss business continuity with customers in the past, I would mention things that they should plan for. One of these was a pandemic. What is your business continuity plan if all your hardware is working just fine, but no one can come to work? What are you going to do then? With hyperconvergence and VDI, the answer is very simple. And we'll talk a little bit more about it in one of the case studies I mentioned towards the end. Many companies interviewed have stated that they're enjoying a lower total cost of ownership by switching to a hyperconverged infrastructure. Consolidating the architecture results in less equipment in the data center, which reduces the power and cooling requirements as well. Reducing the need for specialists in the silos reduces the cost of personnel. Additionally, the ease of deployment and growth reduces the time spent on maintaining the environment, providing more time for personnel to grow the business. In fact, one recent study showed a 62% reduction in the total 5-year cost of operations. Customers interviewed stated they saw an 82% faster deployment of their resources. Hyperconvergence also supports virtual GPUs and desktops. This brings a much better experience to the employees, and we all know that a better experience makes for a better deployment. The goal should be for the employee experience to be better than the physical desktop. With the hardware capabilities and add in the GPUs, there aren't many workloads that VDI on hyperconverged cannot handle. We will talk about one of these later in the customer testimonials. I am sure everybody is familiar with the Citrix Ready program. If you're not, you should look it up. There are a series of virtual appliance vendors who have appliances that will connect directly to the Citrix cloud infrastructure, so you can make it even easier to run a script and connect to the cloud to the hyperconverged infrastructure. You can find the web page in the notes, and we can share it out with everyone. That's going to be the citrixready.com, and look up the hyperconverged workspace appliance program. To make this even easier, Citrix has compiled a list of reference architectures from most of the major vendors, a few of which I've shown here. If you're not familiar with a reference architecture, a reference architecture is a tested and proven build performed by the hardware vendor. They utilize their hardware and testing software and can tell you how many users you can expect to host on a particular hardware configuration, complete with what part numbers to order and use. If you're looking to deploy Hyper-Convergence and want to know where to start, this would be a great place. Now let's talk about a few real-life examples. First, we're going to talk about the Florida Cancer Specialists. They're also known as America Oncology outside of Florida. They have many locations and are supporting, on average, 2,200 concurrent user sessions running Citrix virtual apps and desktops on Nutanix hyperconverged infrastructures. Jamie Terrell stated that working with Citrix at the Georgia Medical Center, started working with Citrix at the Georgia Medical Center, and was more of a Hyper-V user. But he said when I talked to him that Acropolis Hypervisor is winning him over pretty quick. Florida Cancer Specialist utilizes Citrix virtual apps and desktops to provide desktops and applications to the clinicians and nurses, etc., to assist in patient care. They have been running their environment for several years. They are currently investigating deploying FSLogix and app layering, and they are looking at adding Nutanix files to support the FSLogix files and replicate them to the DR facility. Nutanix nodes will be deployed at the DR facility, giving them the business continuity they need. And if you're not familiar with Nutanix files, what it allows you to do is have the same files storage locations replicated between the different clusters, which makes doing FSLogix and your personal profiles and everything block level replication, and it does a great job of keeping up with that. The other nice thing about it is that when you're building your images, you can build your image at one end, and it will replicate that image to the other side, and then you can just control what site they belong to by using a group policy object to register with the delivery controllers in that zone. So it's pretty simple. Here's what Jamie had to say about running Citrix virtual apps and desktops on Hyper-Convergence. Normally there is a trade-off on performance when you start something simple, not when HCI is done right. Not only do you get something that is simple and easy to set up and manage, the performance is on par, if not better than, the most complex design. Shan Venable has been the CTO of Altamaha Bank for 5 years. He's got 30 years of experience, about half of that in the banking industry. At his previous bank, he'd experienced virtualization in Citrix software, so he knew coming into this position that was the direction he wanted to go. Shan knew about Hyper-Convergence, and after looking over several vendors, decided to go with SimpliVity. His first project was to deploy Citrix virtual apps and desktops to the bank. He enjoys the single pane of glass to manage the hypervisor and Hyper-Convergence all in Virtual Center. Remember when I spoke of business continuity? Shannon and his team ran semi-annual tests of their business continuity plans. One of the things that they would do, and I thought this was really innovative, is they would pull a ping pong ball out of a box that had a percentage written on it. If the one they pulled out said 30%, they sent 30% of their workforce home to work for several days. Because of this, when the current COVID situation happened, the bank was able to quickly make the decision to send 50% of their workforce from home to work from home, alternating who was at home and who was at work. They didn't even have to think about, will it work? Can we make it happen? They just went straight up. Because of their success, I wrote a blog article about their use and how it has helped the small bank provide the type of capabilities that the big boys do without breaking the bank, pardon the pun. They have the resources and can support the ever-changing workloads of the bank. You can see that that link will also be posted in the notes. Citrix must have liked my article because they put out a press release a month later. Imitation is the sincerest form of flattery, I guess. The links for these articles will be able to be found in the presentation when it's shared out for everybody. But let's hear what Shan has to say. The all-in-one architecture of HCI makes VDI performance great. Local copies of desktop images removes the storage issues that traditional SAN environments have. Add to that the resiliency of an HCI cluster, and you have a rock-solid solution. And now we're going to talk about my favorite hyper-converged infrastructure environment. Some of you may have been familiar with Citrix works with the Aston Martin Red Bull Racing.
We probably had about 20 different entities we had to work with between, the contractors, production team, safety crews, film crews, city, police, fire, and the whole Citrix team, as well as the Red Bull Racing team.
Aston Martin Red Bull Racing has to go to 21 races a year, so we have a routine. Whereas events like this are a little bit different. There's a lot more parties involved. We've actually been planning this for probably more like 2 or 3 months as opposed to, the week before the race. I've been on calls at like 2 in the morning, communicating with the guys over here in the US from Japan, trying to sort everything out and make sure that we're prepared for this event. Citrix's tools to allow us to collaborate wherever we are in the world. It's really helpful for us when we're traveling that we actually have access to our Citrix digital workspace. We can work as if we are back in the factory. And that's been really helpful to us, particularly from a sort of coordination standpoint, in making sure we can get this event off the ground, quite literally.
This helipad may seem like an extreme work environment, but every day we meet customers who have equally challenging work environments. I think it's at times like this you realize the importance of having a digital workspace where you can actually collaborate with other people and where you can be productive as an individual. Having a common place and a common way to work across all our technologies across the globe is really at the center of what Citrix delivers to our customers. It's really important that our technology supports all of those work styles and lets people decide how and when the technology should work best for them to get their best work done.
A lot of preparation went into this. It's not every day you can bring a car up 700 feet up into the skyline of Miami and get ready for a donut. The outcome is really going to show all that hard work.
I think this is a great celebration of collaboration, and if the cameraman was to turn around, he'd see all the people that are involved in making something wonderful like this happen. So a round of applause, everyone.
Okay, Aston Martin Red Bull Racing decided to work with HPE and Citrix to address the need to provision 2 high-speed spec workstations to each aerodynamics engineer. So what they were doing before was they were having to carry around 2 different Linux workstations that ran high-end graphics communications, and they would do different pieces for the aerodynamics engineers, okay? Then they would have to gather the information from one of the workstations and transfer it over to the other workstation to do their analysis. The first step was to offer a Citrix workspace with Linux VDA for the engineering team. This allowed the users to avoid those 2 physical machines running separate OSs to execute the full process. The pre-processing tasks, which ran complex 3D geometry calculations, and post-process analysis, which had video and more complex geometry, are now rendered and edited with the same Citrix workspace solution. Rather than using separate physical machines, the end users can drag and drop the data between the 2 virtual desktops to support their workflows. Both HPE and Citrix have case studies published on their websites on how they use Hyper-Convergence in their infrastructure, if you'd like to see some more information. By enabling our aerodynamicists to use a unified workspace to support the design processes, they now have the ability to work faster and produce more design iterations. This results in a more optimized design for each circuit and better results on the track. And that's from Matt Sorrell. If you look at their communications on the HPE website, they talk about 8-time reduction in the amount of data, and they were able to run those calculations, went from over 530 seconds down to 110 seconds to be able to do the same calculations. And we all know that in Formula One, seconds can make the difference in a race. The person who sits on the pole and the person who's at the back of the pack is usually separated by a few milliseconds. Okay? So now I'm going to open it up for questions. Let me go ahead and open the Q&A up. I did see one that came up in the group chat. Do you really see linear storage for use with VDI and hyper-converged? And yeah, so I will say that you don't need that much storage, but it is going to be a pretty linear amount because you're going to have a certain amount that you're going to use for your MCS or PBS images that you're going to store it on, and then each of the different users is going to have their profile disk or other functionality. So it's fairly linear, but you're right. And that's why if you look at, like, for example, the HPE hyperconvergence reference architecture, they refer to having 4 compute and storage nodes and 4 compute only nodes, because all they were needing to add on even more users was to put on more CPU and more hard drive space. See if there are any other questions in there. Okay, does anybody else have any questions? All right, I think we're with the no questions popping up in here. I guess we'll just save them for the roundtables. So, are you there, Bob?
I sure am. Thanks, Rich. Appreciate it. Good stuff. Yeah, that was really some in-depth stuff there, and F1 racing, you can't beat that. All right. Well, we're going to be obviously a little bit ahead of time here. But if you want to go ahead and maybe take a break, let's just wrap this up. Please be sure that you're going to the roundtables after this. This is one of those places where you can ask all those questions, finish everything out. Any of those questions that you thought of at the time of the presentation, or anything that might be coming up after that. So head on over to the roundtable, take a little break, and enjoy the rest of your Southeastern XL CUGC.